Hi, welcome to your math class. Today, you, my friend, are going to become a master in trigonometry. This is all you'll need to know in less than 20 minutes. These are the topics we're going to cover. Let's begin. Trigonometry is the study of triangles. There's many types of triangles. We're going to be focusing on right triangles for now. We can identify them because one of their inside angles is 90 degrees. You can write 90 degrees or you can draw this little square. And this also means 90 degrees. This right triangle has three sides, and one of the sides is more important than the others. The hypotenuse is the side opposite to the 90-degree angle, and we can also name this side C. Let's stick with using C for now. The Pythagorean Theorem is this formula, and it's used with right triangles only. Notice how it has three letters, one of which we already have written. A and B are the sides that remain, and it doesn't really matter where you put them. We can name them like this, or like this. I'm gonna leave them this way for the example. The Pythagorean theorem states that the squares of A and B together equal the square of side C. This means that if we draw squares in each side, the square of C should be equal to what we get if we combine squares A and B. Let's compare the squares on the side here. On a first glance, B seems like it can't fit. But if we cut it into pieces, and we reorganize these pieces in a certain way, we suddenly get the same area. This formula is very useful when we have two sides of a right triangle, and we want to get a third side. For example, the first triangle has two sides, the two not so important sides. And because we have two sides and one the other side, we're going to use the Pythagorean theorem. The first step is to name the sides. The hypotenuse is C, and the other two are going to be A and B. Then we're going to put the values we know in the formula. The 3 in the A and the 4 in the B. After that, we solve the equation. For the math pros, this is not the complete way to solve it, but it's what we need for now. And that is the answer. For the second example, because we have two sides and one another, we write the Pythagorean theorem. Then, we name the sides of the triangle. After that, we're going to substitute the values of the letters into the formula. The third step is to solve the equation and we get the answer. And that is how we use the Pythagorean theorem. Special triangles. Why so special? They're special because of their inside angles. Notice one has 30, 60, and 90 degree angles. The other one has 190 and two 45 degree angles. Depending on your teacher, either you'll need to learn these or not. If you do, worry not. Try learning it this way. The 45 is the easiest triangle. It has two sides that measure n, and the other side is n times a square root. The 30-60 triangle has a super small side opposite to the 30 degree angle, worth n. The hypotenuse is worth 2n, and the opposite side to the 60 degree angle is n times a square root. To easily learn what goes inside the square roots, you'll ask the triangle how many sides with different lengths does it have. The 30-60 triangle has 3 sides with different lengths, and the 45 triangle only has 2 sides with different lengths. To solve problems with special triangles, we need the reference of the special triangles somewhere. Problem 1. Find x. You might know there's a rule that says that all triangles have inside them 180 degrees in total. If we know there's a 90 degree angle and a 60 degree angle, the missing angle should add up to 180 degrees. That way we can solve for the missing angle. Now to find A, we need to know which of the two special triangles we're going to use. Since we have a 30-60 triangle, we're going to use this one as a reference. The simplest way to solve this is to make a little table to solve with rule of 3. Now, the problem gave us a side already, and we know we want side A. We put that information into the top row. It's important to know that because of how I wrote the values in the table, the left column now will be for the shortest sides, since A is the shortest side or opposite to the 30 degree angle, and the right column is going to be for the middle-sized sides, or for the sides opposite to the 60 degree angle. Now, in the bottom row, we fill the corresponding sides from the reference triangle. In the left column, we write the shortest side, or the side opposite to the 30 degree angle, worth n. And in the right column, we put the middle side, or the side opposite to the 60 degree angle, worth n times square root of 3. To solve simple rules of 3, from the value we want, the neighboring values will multiply, and then the furthest value divides the product of that multiplication. So we can write that like n times 3 times square root of 3 all over n times square root of 3. We then can simplify this by canceling out the n and square root of 3. So the answer for A is 3. To find C, there's the fast way and the simple way. The fast way is to know that we have the shortest side already, worth 3 units, and C is twice that side, so 6, and that's it. The simple way is the rule of 3. This one always works, so you can use this method when you're not sure on your answer. We bring the table, and on top we write from the problem what we have and what we want. And at the bottom, the corresponding sides from the reference triangle. We multiply diagonally and divide. After solving, we also get 6. The 45-degree triangles work the same, but the reference triangle is the other one. To first find A, we see that the side A is actually equal to the side with the 7, so that's the answer for A. To find B, you can either notice B is the same as the other sides, multiplied by a square root of 2, so the answer is 7 multiplied by the square root of 2. Or if you doubt anything, use the rule of 3. We have a side worth 7, and we want side B. The reference triangle has corresponding sides equal to n, and n times square root of 2. Multiply diagonally the neighbors to the desired value, then divide, and you get the same answer. Trigonometric functions, or commonly known as SOH CAH TOA. We use the trigonometric functions in right triangles when we work with angles and sides in general. SOH CAH TOA is a short for these equations, and the letters on the right mean opposite for O, hypotenuse for H, and adjacent for A. To use SOH CAH TOA, you only need to remember 2 things. The SOH CAH TOA equations that we just saw, and that you have to always stand by or select one angle that is not the 90-degree angle. Let's do the first problem. First, I'm going to write the SOH CAH TOA equations on the side. Because we want angle theta, that's 0 with a belt, we're going to select that angle and not the other one. You're going to see why that's important in a second. Okay, so for sine or so in SOH CAH TOA, we know that in the numerator goes the opposite, and then the denominator the hypotenuse. The opposite side is the side in front of the angle we selected, so 3 in this case. The hypotenuse is always opposite to the right angle. In this case, the hypotenuse is 5. For cosine, or CAH in the SOH CAH TOA, we know that in the numerator goes the adjacent side, which you can also remember as a long side, because it's the side next to the angle we selected, so 4 in this case. In the denominator goes the hypotenuse, which is 5. And for tangent, the TOA, in the numerator goes the opposite side of her angle, which is 3. And the adjacent side is the denominator, which is 4. These are the ratios, and if they ask you for the ratios, we're done. That's the answer. Sometimes they also ask for the reciprocal operations, which are cosecant, secant, and cotangent. These are the reciprocals of sine, cosine, and tangent, in that order, and you just flip the fraction to get the correct ratio. That is how you obtain the ratios. Now, if we selected the other angle, let's say angle x instead of theta, all the ratios would be wrong, because notice how x and theta have different opposite sides and adjacent sides, and there would be flipped ratios. But what happens if you want the angle in degrees and not in a ratio? To do that, we can solve for theta in each small equation. We treat theta like a variable and just solve for it. Notice how in the 3 equations we have, the variable is inside a trigonometric function. The trigonometric functions can be sent to the other side of the equation as their opposite, like this. And you simply put this into your calculator and you get the angle you wanted. That's how you get an angle, and you can do it with the other equations as well. Let's do this harder example. We have an angle and one side, and we want another side. We know we can use SOH CAH TOA because we only have one side. If we had 2, we could use Pythagorean Theorem, but that's not the case. SOH CAH TOA is used when you have one side and one angle, or 2 sides, and you can get all the angles and sides. To know which trigonometric function serves us the best, we have to select an angle. We can select the angle we know, that measures 50 degrees, or we can get the missing angle, but I'd rather not do that, so I'm selecting the 50-degree angle. Now that we have an angle selected, let's see which sides we want or have. We have the side that's opposite to the angle, and we want the side that's adjacent to our angle. Now we need to find a trigonometric function from SOH CAH TOA that has the letters O for the opposite and A for adjacent. That function is going to be tangent, and because the angle we selected is known, we write it in the function. Then you just need to plug the values of the sides we have or need into this equation. We have an opposite side that measures 5, and we have an adjacent side that's worth x, or at least for now. Now we're going to solve for x. Because it is in the denominator, I'm going to pass it to the other side, multiplying. Now, since tangent of 50 is multiplying x, we can pass it to the other side as a division. Finally, you'll type this into your calculator and you'll get the answer. And that is how you use SOH CAH TOA. Law of sines and law of cosines. These formulas are used in triangles that are not necessarily right triangles. Usually, when you deal with right triangles, SOH CAH TOA is used because it's a little easier. Law of sines is used with triangles AAS or SSA, which means that you can use law of sines when you've got in your triangle 2 angles and 1 side, or 2 sides and 1 angle. Law of cosines can be used with triangles with SSS and SAS, which means you can use it when you have 3 sides given, or 2 sides and 1 angle, but that angle corresponds to a side you don't have yet. And how do we use these formulas? First, we need to know which to use. In this problem, we have 2 angles and 1 side. This side corresponds to an angle we know, so we can use law of sines. You usually want to work with law of sines because it's easier. If there's a way to avoid using law of cosines and use law of sines instead, definitely do that. A tip when using law of sines is if you flip the formulas, it works just as fine. That makes learning the formula much easier. We now look for what we have and what we want. We do have angle B and side B, so we can write that side first. Then we notice we want side C, and the angle corresponding to that side is 42 degrees, so we write that down. We now have to solve for the variable we have, and you can do that in several ways. Cross multiplying, rule of 3, or just solving for the variable normally. I'll just solve normally. And now, you just put this into your calculator, set to degrees, and you get the answer. But what would happen if they ask us for side A instead of side B? Notice we don't have angle A, so instead of using law of cosines, we can better get the missing angle by knowing that all the angles in a triangle add up to 180 degrees. So the missing angle is 103 degrees. Now you would do the same, but for sine of 103 degrees instead of 42. To solve this other problem, we notice we have 3 sides and no angles. Law of sines needs at least one angle, so we're gonna have to use law of cosines this time. The formulas I have written here work better when you look for a side length. However, most times you're gonna use law of cosines to find angles. So there's this variant that will make our lives 20 times easier. You just plug the data into it and get the answer. Because we want angle C, we're gonna choose this side to use its formula. So the formula for C. We get the values for sides A and B, which are the sides we didn't choose, so 9 and 5. And side C is the side we chose, and that side measures 8. So we write it into the formula as well. Now, because we want an angle, in other words, the C by itself, not with a cosine, the cosine function has to go. We can send it into the other side as its opposite. You now type this into your calculator and you get the answer. Using law of cosines is not that hard if you understand the pattern of the formulas. Notice how, for example, in this formula, we want side A. So we add the sides we didn't choose squared, then subtract 2 times the 2 sides we didn't choose, times the cosine of the angle we chose. That pattern continues with the formulas for B and C, and even the formulas below have a similar pattern. Take a little moment to look at them and figure the pattern out. This is important to know because many students struggle on knowing what happens if the sides are not labeled ABC, or if they're flipped, or in whatever combination. The answer to that is to understand that pattern and use the formula as a pattern. Finally, what would have happened if they asked us also for side A? Well, because we now have angle C, you can actually use law of sines, but pretending we don't have angle C yet, we would use the formula for A. We input the value the problem gave us and solve in a similar manner. And that is how you use law of sines and law of cosines. That was the full trigonometry class. I really hope it helped, that you learned something, and that you do great on your exams. See you soon, and God bless you. Bye bye.